How do you graph a polynomial function like this without technology, just using derivatives and sign charts? So there's about 5 steps here that I'll pull over. And we'll follow these, first finding the derivative and finding the critical points using f prime of x equals 0. We'll make a sign chart and determine those extrema, which are just minima and maxima. And then we'll repeat that with the second derivative, which will have critical points that are considered inflection points. And then we'll sketch a graph using those points that we plot. Okay, so starting with step 1, let's figure out what is the derivative. First derivative of this function f of x. We're going to use power rule for the most part to find this derivative. So step 1, f prime is equal to, bring the 3 down, get 3x squared. Bring the 2 down, this is just 2 times 1/2, so that cancels to give us x minus 2, and the final constant of 1 has a 0 derivative. Next, let's set that equal to 0. And this gives us a quadratic function, so you can use several different techniques to figure out the zeros here. You could try to factor by brute force, which is what I like to do, but sure, a certain way to get the zeros of something like this is to use the quadratic formula. So on the side here, you can use quadratic formula if you'd like. Which is negative b plus or minus the square root b squared minus 4ac all over 2a produces usually at least 2 solutions. So I did this earlier, and I know that the factored version should be, I forget what's the right order here. Let's give it a shot. I believe 3x minus 2 times x plus 1 will be the factors. Yeah, so this negative 2 plus 3, yeah, that works. No, sorry, other way around. So it's plus 2 and then minus 1 for the second binomial here. Trial and error. Great. So that will give us 2 solutions here. The first one will be a negative 2/3, or we'll have a positive 1. These aren't solutions of the original function, but remember, this is just f prime. We're working on the first step that we just completed here. And step 2 is going to be creating a sign chart out of these. So step 2, let's move over to the right. I like to draw them on a number line. We'll have the negative 2/3 first, positive 1 in order. And as you know, in a side chart, we're going to pick some values that are in the intervals around these critical points. So anywhere in these intervals, I like to pick the easiest numbers as possible. So maybe here we'll pick a negative 1 to plug in. 0 is in between negative 2/3 and 1, and a 2. And let's see what we get. Remember, f prime is the function we found in step 1. So 3x squared minus x minus 2. Now this is a sign chart. So remember, we only care about the sign, not necessarily what the exact value is. So we'll see if we get like positives or negatives at the top to tell us the direction of the function. So we plug in a negative 1 into this function, get 3 times negative 1 squared root of this 1. That gives me a 3 times positive 1, 3. Minus negative 1 is 3 plus 1. So that's 4 minus 2. It's going to be a positive 2. So again, I just care about the fact that it's a positive number. So I'm going to write a positive there. And then for the other ones, when you plug in 0, that becomes a negative 2. If you plug it in this way. And then when you plug in a positive 2, I believe that becomes positive. Yeah, this will be a positive value. Okay, great. So that means in the interval in here, we have positive or increasing values, right? So I like to indicate that with a increasing arrow. And then in this interval, we got negative or decreasing values. So then I use decreasing arrow, -1, like that. And then for the last one, we're positive again. This actually already tells you what the extrema are, as step number 2 suggested. So that tells us that this -2/3 is happening in between increasing and then decreasing values. So that indicates we have a maximum right there, a maximum value. Okay, and then when we get to the critical value of +1, we're going in a decreasing direction and then increasing again. So that only happens if you have a minimum at that point. So x equals +1 was, or will be, our minimum when we get to the sketch of the graph. Great, so step 2 done. Let's do all that, repeat it again, of finding a derivative a second time and creating sign charts for step 3 and 4. So if f prime was 3x squared minus x minus 2, use the power rule again to get this down to f the double prime, that's 6x minus 1. And then set that equal to 0. So the only critical value we get here is a 1/6. That's going to be an inflection point, not necessarily an extrema, like a minimum or maximum. So we need to know whether this is inflection going from concave up to down or concave down to up. We'll determine. So we do that with a sign chart, or step 4. Smaller one, since we only have one critical point there. Again, pick values, any values easiest for you to plug into those intervals to the left and right of 1/6. I'm going to pick 0 and 1. So plugging in 0 into here, definitely a negative. But now remember that indicates concavity, right? Not increasing or decreasing. So I'll show that later. Let's finish this off. We get a +5. I just care again about the sign being positive. So now how I indicate these signs on this sign chart is going to be negative or a concave down shape, positive concave up shape, like that. And we have almost everything we need to sketch our graph now. What we're going to do for the final step 5. Oh, forgot to do the little check. Check, check. Plot points, sketch a graph. So which points are we going to plot? The critical points we got from either of these steps in derivatives. So we had these values, or maybe I should highlight. Over here, those x values are important. And finally, our one inflection point of 1/6, that is also important. And now these are going to get plugged into the original function f of x, in case we need to see what that looks like again. That was this here. And those values that we're plugging in were the -2/3, +1/6, and the 1. Okay, so when you plug into this function, but you can have a calculator do that for you. I have my calculator here. Plug in -2/3, so I'm going to just be really careful with plugging in. Raise that to the third, minus 1/2 times x squared, so -2/3 squared. And minus 2 times negative 2/3. Finally, plus 1, just plugging everything negative 2/3 into that entire equation, get a 1.81. Great, 2 more to go. Okay, 1/6, I'll put in parentheses, 1/6 to the 3rd power minus 1/2, 1/6 squared. Minus 2 times 1/6. Okay, great, the last part, plus 1. 0.66, we'll round it. Okay, final one is one that I don't think I need a calculator. You get 1 to the 3rd, which is 1. And 1/2, 1 times anything is itself. So a lot of this is just an identity here. And I think we end up with, yeah, 2 minus 2, 0, negative 1/2. Or I'll leave it all in decimal form. So let's see if we can sketch something out of all this. We had pretty small values to work with. So at negative 2/3, that's about negative 0.6. We're up here at 1.81. And then at 1/6, we're really close here in the positive x region. We're up to 0.66. It's our inflection point. And then at 1, we're at negative 0.5, right there. And let's recall the information we found from the previous steps, what's happening at all of these. We said the first point was going to be our maximum. So this point is going to be a maximum. And then positive 1 over here is a minimum. And then we also know that any region that comes before that positive 1/6, which means this whole region here will have this shape of concave down, whereas everything to the right of 1/6, that means that everything from here to the right, concave up shape. So that's enough information for us to determine that we have something going in that direction and shape is pretty good. And that's going to be our sketch. These points here, not too sure what those were because this was a sketch. But we can check now with technology. We'll go to Desmos and see what we've got, if it matches up. And there's the graph already more accurately graphed in Desmos, and it puts in for you what those critical points were, which matches up with what we got. That negative 2/3 or maximum happened at 1.81. The minimum happened at positive 1, negative 0.5, and inflection point 0, 1. Or sorry, the inflection point, yeah, actually happens somewhere here. I think that was just, yeah, this is just a y-intercept. They put the intercepts for us here. And inflection point happens right somewhere in the middle here, where we found it at that positive 1/6, where it changes from concave down to concave up. That's how you graph using derivatives and sign charts.